Hello students and welcome to this calculus lesson. In this lesson, we're going to start learning about how to find area between two curves. Kind of alluded to this in previous lessons, so let's get started. So as we start to do this introduction, we start to explore how to find the area between two curves. Let's kind of go through this. Our very first problem is going to be something that we've done before, or like we've actually done this concept, is we want to just find the integral and graph this function from -5 to 0. We're going to put this graph in, and I know that this is going to start here at -2, 6. Great. And then it goes down half a point right there. So graph this function.
There's no telling what you want me creating. We're on the same wavelength. Feel the beat tonight. Something good inside. Set you free. Let you lose all track of time. Come on, have a conversation.
And what is this area that this is supposed to represent? Well, we're going here from -5 down over to 0. And we're going to shade this in. So it's going to be everything right here, all the way down to the x-axis, okay? What I want to do is let's actually go and find the value from -5 to 0 f of x dx. So that's going to be the integral from -5 to 0, -1/2 x squared minus 2x plus 4 dx. Okay, so the antiderivative for that is going to be -1/6 x to the third minus x squared plus 4x, and we are going to evaluate this from -5 to 0. Okay, so I'm going to plug in 0 and -5. Obviously with the 0, that's going to come out to be 0 minus -1/6 -5 to the third minus -5 squared plus 4 times -5. Okay, and you're going to put all of this into your calculator, and this is going to come out to be about 24.167. So we found the area under the curve for this function. So now what I want to do is I want to graph the function on the same graph. I want to graph the function g of x equals to 1/2 x plus 4. And we go from here to here. This is a linear function. I'm going to connect those just like that. So if we shade in the area where I'm going from upper to lower, it's going to be right here. All right, so all the way down to the x-axis, that's what we're finding. And now I actually want to find, okay, what is this value equal to? So we're going to find the integral from -5 to 0 of 1/2 x plus 4 dx, which is going to get me 1/4 x squared plus 4x, and we're going to evaluate this from -5 to 0. So of course, again, like the last problem, we're going to get 0 minus 1/4 times -5 squared plus 4 times -5. All right, you put that into your calculator, you're going to get about 13.75. So as we move on, what do you suppose that this is located in between the graphs of f of x and g of x? Okay, we want to find this value. So I'm looking to see, okay, what is in between right here between these two graphs between f of x and g of x? So what is that space in between those two curves? Well, we kind of know this is if I can take the entire region and subtract the part that I don't need, so the entire region up to f of x, and subtract g of x, then we're going to get, okay, so that was 24.167 minus 13.75 here, and this is going to come out to be 10.417. And that's how much area there should be there. So now what I want us to do is, okay, so now that we know what f of x is, we know what g of x is, we want to combine them together. Don't do separate integrals. Put them all together and see if we can get the same answer. Let's see what we can do here. We've already done work like this, so we're going to speed up the video and see if we do all that same work again.
Something good inside. Set you free. Let you lose all track of time. Come on, have a conversation. Don't treat me like a stranger. You give me motivation. Make my life vacation when we are together.
All right, so you're going to put this into your calculator. You're going to get 10.417. What you want to notice about this value is that they're the exact same. 10.417 up there, 10.417 over here. We got them to be the exact same. So that means that, all right, if I had the separation of those two functions and we just calculate both those integrals and we subtract them, that they're equivalent. So this is going to help us explain, okay, how do we find the general way to find area between two curves? So there's something that we just want to keep in mind. In order to find the area between f of x and g of x, the area between two curves, you're just going to find where those points of intersection are, and then you're going to do the upper function minus the lower function. And in some cases, we could find where those y points are intersecting, not the x values, and we could do the right function minus the left function in some very specific cases. The one thing that you're always going to want to keep in mind is that it says f of x minus g of x is the upper minus the lower, but you always just want to keep in mind, like, depending on how these functions work out, especially if things flip, which we're going to be looking at in a later problem in a later video. But those functions can change, and those points of intersection can change. So you're always going to want to determine, okay, which one is greater, which one is the upper function, which one is the lower function, especially if you're not given a graph in every case. So let's go ahead and look at this next problem where we want to find the area of the shaded region. This is pulled completely from a free response question. Every single year, you're going to have to do this in a multiple choice question and a free response question. So looking at these two, I can immediately tell that, all right, we have a sinusoid and a cubic function. So here we have, we're going to say this one is f of x, which is sine, and then this one is g of x here, which is going to be my cubic function down there. Okay, so we immediately know from the graph which one is our sinusoid and which one is our cubic function. But if we didn't, we could do a sign chart of using something in between these values after we find the points of intersection. So we can see, again, that the points of intersection here are at 0 and at 2. Those are going to be our limits of integration. But as we're doing this, if we didn't have this information, we would set these functions equal to each other, figure out where those intersection points were happening, and then within those intersections, we could do a sign chart to see, okay, what is the sign? What are these values? Which one is greater than? Which one is less than at certain points within this interval from 0 to 2? But since we get everything from the graph, let's go ahead and solve it. So we know we're having an interval here between 0 and 2. We know the upper function is going to be sine of pi x, right? And then we're going to subtract it from the lower function, which is going to be x cubed minus 4x dx. So what you want to always do is simplify this and then go. So let's go ahead and simplify this and actually integrate.
Baby girl, you're so fine, I can't get you off my mind. Ooh girl, nah, nah. Ooh girl, nah, nah. Baby girl, don't need to flex, dance to the rhythm and you do all the rest. Ooh girl. When I'm done, lift me up with your company. There's no telling what you want me creating.
Okay, so my final answer comes out to be +4. So some things that I want us to take a note of is that what I actually ended up doing to make this process a little bit easier was I did end up separating the two functions, right? I wrote it as one integral from 0 to 2 of my upper minus the lower function. But when I actually integrated the first one, I noticed here that I'm going to need a chain rule problem, which we covered in a previous lesson. And so I kind of made that pattern happen as two separate integrals because I didn't want to go through the effort of keeping it all together and making everything really hectic. So from there, I kind of just calculated both integrals separately. I'm looking at what cancels out, and then I get minus the 4 minus 8 in parentheses and coming out to be +4. So that's the area of this region over there. Is that, look at that region, it is so curvy, right? It doesn't look like it comes out to an exact value. Like, how can that come out to an exact value? But it does. Things are canceling out as we go. The pi's are canceling out, those curves are canceling out. So this does come out to be a positive natural number. We're gonna have 2 more videos in this lesson where we're covering more practice problems, finding area between two curves, what I mean by when you have to change the bounds of integration halfway through. So we're going to be looking at those types of problems. Of course, if you do need any help in this video, if you need some more understanding, reach out to me either in the comments below or in a message, a private message. Go ahead and reach out to me. I am Mr. Hernandez, and this was Mr. Hernandez Teaches.
Don't need to flex, dance to the rhythm and you do all the rest.